Okay, so I'm going to start doing absolute value inequalities, but I'm going to start with an equality just to get the idea of what to do. Now, just you have to keep in mind that absolute value is the distance to zero on the number line. And there are always, whatever the unit is, miles, inches, feet, yards, whatever, there's always two numbers that have an equal distance to zero, like the number three and the number -3. They're both like 3 miles from zero. So there's always two answers to these questions. I see a lot of students really screw this up. The first thing you have to do, you cannot solve this while it's like this. You have to get the absolute value alone. So I'm going to get everything that's not inside of it away from it. So I'm going to cross that out. Subtract one over there, you get 9. I'm going to divide by 3. Right? This is step one. And then 9 divided by 3 is 3. So there's a reason I just picked 3. What I just did. Whatever number is living in there, that number can be 3. Right? Its distance to zero is 3. So the number could be 3. But it could also be -3. And you have to account for both of these. Now notice, no bars, no bars. The solving move drops the bars. The bars aren't there anymore. So now I need to solve. This is fourth grade math here. Add 5, get 2x equals 8. Divide by 2. So that means that x could be 4. Or, and again, I'm going to add 5 on this side, right? 5 take away 3 is 2. So then divide, and then that means that x could be 1 also. So either of those numbers, if you put them back in the original, will have the correct distance to zero, right? That's all you're looking for is the distance. Now I'm going to do the absolute value inequalities. That's why I want to do this one first, because I'm not going to make a separate video for one stupid thing. Now, they're very redundant. Once I show you how to do one example of each, that's just, at that point, it's just repetitive. So I'll do one of each type. Okay, so the example that I decided to work, I actually took off of practice exam 1, number 4. I'm going to do A and B because this is what will be on the test. So here you have the absolute value is smaller than 11. So what I'm saying to you is that I'm looking for numbers that are within 11 units of zero, right? So that means you're going to be close. So you should expect an answer that's one single interval trapped between two numbers here. Now, it's not going to be 11 and -11, but that's the gist of it, right? I'm looking for numbers to put here for x that will create a distance that is within 11 of zero. So when you do this one, right, the technique I taught you was very simple. You don't want to get cute with this. I told you drop the bars and then just reverse it, right? Create a little sandwich. Just put 11 here and then put -11 here. You have to be very careful with this. I see students put this thing all over the place. I see students write really ridiculous things here. What I'm writing is this. I'm only going to write it once. I can be less than 11 and at the exact same time bigger than -11. This is not or, this is and. You need numbers that satisfy both of these together. That's why I'm doing it as one huge inequality. So this is and. But look, that's what I have. I have that 2x minus 3 is less than 11 right there. Over here, I have 2x minus 3 bigger. Look where the mouth is facing the bigger thing. So I don't want to do two separate ones here. When I can do one simultaneously, it's much easier to do this. That's why I do it this way. So the bars got dropped. Don't put bars here. Bars here is wrong. So now I'm going to add 3. Right? You're solving basically two inequalities at the same time. Cross that out. So that means the 2x is less than 14. Or bigger than -8, right? Be careful with the minuses. Subtract the numbers, keep the bigger sign. Divide everything by 2. That means that x has to be between 7 and -4. That's it, it's done. I can put it on the number line just for myself, but you don't need to. You can just write the interval from here. X has to be living inside of here. Look, I'm going to pick some random number there after I write the answer. So answer is between, not including, right? I put less than, not less than or equal to. If it was less than or equal to, I'd put a bracket and those would be colored in. So the number 7 and the number -4 aren't going to work, but I could pick any number between them. So look, I'm going to pick -1. I'm going to put -1 up there and show you that it's true. This distance is going to be less than 11. 2 times -1 is -2, right? Still inside the bars. -2 minus 3 is -5. Less than 11, less than 11. Absolute value of -5 is 5. That is less than 11. True, it worked. Now check this out. I'll pick a number bigger. I'll pick 8. I'll pick a number that's not in that range. Absolute value of 2 times 8 minus 3, less than 11. That's 16 minus 3. That's 13. Absolute value of 13 is 13. Is 13 less than 11? No, it's not. False. So, I mean, you see that the only way this will be true is if you would pick the number between 7 and -4. All right, and that's exactly how it's not a lot to this. Drop the bars, make your little sandwich, right? Sandwich this dude between the number and the negative of that number. Make sure the mouths are facing the same way, and then just solve it, right? At the same time. It's very, very simple to do. You don't have to make the number line. I mean, unless I say sketch the solution on the number line and then write the answer as an interval, which I might say that. So if I say that, then you make the number line. All right, so now I'm going to do one where it's bigger than. Okay, so I really like this one because I know it really matches up to the one that I have on the exam. And this is I'll always do this because I know I get 0. Now, I'm looking for numbers whose distance to 0 is bigger than 6. So look, there's 6, there's -6. They're each the same distance to 0. This is 6 units away, this is 6 units away. But I want numbers that are further away than that. Look at that. So they're going to be all the way out there, all the way out there. So I want numbers that are out here or out there. That's the reason this is an or. The last one was an and because I was close to 0. I am far from 0. So, but the game is the same. I am going to make an exact copy of what I see. Drop the bars, drop the bars. You write bars here wrong. So I want numbers that satisfy this or satisfy being less than or equal to -6, right? Flip that, switch that. Flip, switch. This thing flipped the other way, that's switched. Now I'm going to solve them both. Now, this is why I like this question. When you subtract 6 over here, you get 0. People get confused. It's easy to get confused. But when you divide by 3, you just have x must be bigger than or equal to 0. Or, now you write it. I write it in the beginning and I write it at the end. I'm going to subtract 6 here. That tells me that 3x has to be less than or equal to -12. And I'm going to divide by 3 again. That means that x had to be smaller than or equal to -4. So that's in 2 very different places. Numbers bigger than 0, there's 0. Now it's bigger than or equal to. That means that 0 will work. So I'm looking for numbers out in that direction. And I want numbers that are smaller than or equal to -4. So again, I'm going to color in the dot. And I want numbers that are living out there. So when you write this as an interval, remember, what's way out that way? -infinity. What's way out that way? +infinity. You have to write the interval. A lot of people are writing these backwards. They're writing -4, -infinity. They're writing weird things. You got to write them in the order that they appear on the number line. That's why I'm putting the numbers on the number line. So the first interval is all the numbers that are between -infinity and -4. This time I am including -4, so bracket. Union, again, including 0, all the way to infinity. So this is my number line solution. I mean, this is the solution. This is the solution graphically on the number line, and then this is the actual interval that tells you where you can pick numbers from. Look, if I pick the number 1 and put it up there, 3 times 1 is 3. 3 plus 6 is 9. Absolute value of 9 is bigger than or equal to 6. Now I'll try a different number. I'll try -5, just to show you that it works. You don't have to check this. 3 times -5 is -15. -15, right? You owe me 15, you pay me 6, that means you still owe me 9. And the absolute value of 9, a -9 is 9. And is that bigger than or equal to 6? It is bigger than or equal to 6. Any number that you pick out here and out there will work. If I picked a number in the middle there, like 1. Oh, how about 1, moron? I'm like, that's not, I just picked 1. if I pick -1, right? I'm looking for a number between -4, so I pick -1. If I put -1 up there, right, you get -3 plus 6, which is 3, right? 6 take away 3, but 3 is not bigger than or equal to 6, right? It doesn't work. So look, you can check in your head or check on scrap paper just to make sure that the numbers that you got in the right regions they work. But in general, you don't have to do this. I'm just showing you because what the hell, I'm only doing two of them. So I want to show you that the numbers I got. So my numbers were either here or here. You cannot do this simultaneously. I do see students try to do this weird thing where they put the mouth this way and then they put the mouth this way. I mean, this doesn't make any sense. This is trying to tell me that these numbers are bigger than 6 and at the same time, right? Bigger than -6, or they'll do this one. I'm sorry, I messed it up. They'll do this. They'll tell me that the number is bigger than 6 and at the exact same time smaller than -6. That doesn't happen. This is complete bullshit. So don't write this. Write this, it's going to be wrong. All right, so hopefully that helps. I mean, after this, any example I did after this is one of those two things, a bigger than or a less than. And it's redundant. So I did the two examples and should be all you need to see. So hopefully that's helpful.